All right, I'm glad to be here tonight and talk about something really cool that's coming up in the next month. How many of you are very excited for the total solar eclipse that's happening? Woo. All right, so yeah, the Great American Solar Eclipse of 2017 is happening in just a little over a month. And so let's talk a little bit about solar eclipses, what to expect, and what we can see from the one that's coming up. The reason why this one is so exciting is that the path of totality is crossing over the entire continental U.S., and so many places in the U.S. you can go to and actually experience totality. All states in the U.S. are going to have some form of a partial eclipse, so even us here in Texas will have a form of partial eclipse. And this has been the first total solar eclipse that we've had that's passed over even some portion of the U.S. Since 1979. So it's been a long time, over 38 years, and kind of a fun fact, I was the last one in 1979 was February 1979, and that was 1 month before I was born. So I was not there to see it, but I actually was in the path of totality. It only went over a small portion of the U.S., kind of through Oregon, Washington, Montana, Idaho, but I was there. It's in my mom's tummy in Oregon, so I was there in totality. But now I'm really going to get to see one for the first time, so very excited about that. But what are we going to look for, and what kind of things might we want to know about why we're actually getting this kind of phenomenal event that's happening here? Well, for a solar eclipse a total solar eclipse to happen, for any solar eclipse, you actually have to have the moon in its new phase. And so this is important. We want the moon to be in between us, the Earth, and the sun. And so even though we think that this might be kind of a rare phenomenon, we don't have them happening, at least in the US, all that often, actually solar eclipses themselves, some form of them, totality, partial, annular, are actually not as rare as we might come to think. They actually happen about twice per year, sometimes a slightly longer time scale, sometimes slightly shorter. But they actually are happening somewhere on Earth on about that time scale. And so to be in a place where this is actually happening, you need to be in a place where the moon's shadow is falling on your location. And for totality, you need the moon's umbra shadow, and we'll show a picture here in just a second, for it to be, which is the darkest center point of the shadow. You need to be in the umbra to see a total eclipse. You can be in the moon's penumbra, which is a much larger area, but it's the lighter kind of outer part of the shadow, and that will cause a partial solar eclipse. So here's just sort of a nice diagram highlighting kind of the geometry of what's happening when we're going to have our total solar eclipse coming up here in a month. You can see the path of the moon's orbit around the Earth and how it's directly aligned between the sun and the Earth. And you have the umbra shadow, again, which is that center part, the darkest part of the shadow, which is where you'll have totality. And the penumbra is kind of going on the outsides. It's a lighter part of the shadow, and that's where you'll have a partial eclipse. Here's sort of another kind of cartoon version of this diagram. Again, not to scale here in actual size, but you can kind of see sort of a zoomed-in version here of where we would have totality on the Earth and the larger penumbral shadow. But yeah, just to kind of highlight, right? If this is to scale, the sun's got to be much farther away. The Earth and the moon have to be much farther away. The Earth and the moon have to be about 30 times the diameter of the Earth apart from each other. And then the sun's hundreds of times farther than that. But this is what's going to happen. The moon and the Earth and the sun are lined up. They're at the right angle. We're having new moon, and the orbit of the moon around the Earth is actually at the right angle. It's not inclined offset, which is what normally happens and why we don't have a solar eclipse every new moon. And this kind of really nicely highlights that effect, right? The moon's orbit is actually inclined about 5 degrees off of what we call the ecliptic path, so the apparent path of the Earth or the sun through Earth's sky, or the Earth around the sun. And so the ecliptic is shown there as that blue line, and then you have the orbit of the Earth and the moon by that red line. And so it's only where you have those kind of intersections between the moon's apparent path, its orbital path, and the ecliptic path of the Earth and the sun is where you'll have an actual solar eclipse. And so those two nodes can happen about twice a year, and that's when we will get a solar eclipse. So even though they're not happening every month, they're not as rare as one might think, or we don't see it as often highlighted in the news. But when it is happening at your location, it's obviously a really big event and sometimes can be an even once-in-a-lifetime event. So here's just kind of showing you a map of the United States, as well as more of all of North America, even going into parts of South America and other continents, a little bit of Africa, are going to experience some form of this eclipse. So all of the United States is going to experience some form of a partial solar eclipse. Again, it goes even down into parts of South America and extends all the way up into North America. And that yellow kind of line there is actually showing the path of totality. So if you're lucky enough to be on one of those lines is where you really get the full experience, the full benefit of seeing this solar eclipse. And those kind of, if you can read those, the red numbers there are kind of showing you the percentages. You can kind of find our location there. You can see where in Texas, we're somewhere usually between about 60 to 70%. So we'll have, a decent amount of a partial eclipse coverage here. All right, so a few more details. When is this actually happening? We said it's August 21st, 2017. The first point of contact is going to hit in Oregon, near the city of Lincoln City, Oregon, so right on the coast. It's going to hit there just a little after partial solar eclipse will start, so a little after 9 a.m. Pacific time. If you're lucky enough to be near the city of Carbondale, Illinois, you're going to actually have the longest point of totality, just over 2.5 minutes. And totality can range depending on the type of solar eclipse. On average, if you're near the central line of totality for this eclipse, the totality will last on order about 2 minutes to 2.5 minutes. If you're near kind of one of the edges of the totality line, you might only get the total solar eclipse lasting for 50 seconds or a minute. Some solar eclipses, depending on the geometry, can last even longer. You can have totality that goes for 4 or 5 or 6 minutes. But we're kind of at the shorter end of this one, but still a good amount of totality that you would get if you're on one of these good points here. Another kind of cool thing to think about it is how wide is that swath of totality that's crossing the continental U.S. And it's not very wide. On average, the width of that totality path for this eclipse ranges from about 60 to 70 miles. I think the widest it gets is about 71 miles wide. So you've got to be in this kind of narrow swath across the country to actually experience this. And then the last kind of luckiest people that are going to experience this, it starts in Oregon, kind of crosses down from sort of the northwest part of the country all the way down to the southeast, is in South Carolina near Charleston. They'll have their totality kind of happening right around 2:48 Eastern Time, and even the penumbral part, the lunar shadow, is going to leave the U.S. a little after 4 p.m. Eastern Time. So coming up, I have a few kind of little animations to try to highlight what's the geometry, what's actually going on, and why this doesn't occur all the time. So as you watch this movie, this animation that's playing here, this is trying to show the orbit of the moon around the Earth kind of in the months leading up right prior to the August 21st event. And so when you look at it kind of from that face-on view, it just looks like it's a normal orbit. But when they switch it to this side view, you can actually see that the eclipse shadow normally of the moon was missing the Earth. And it's not until it's perfectly lined up on August 21st that umbral and penumbral shadow is actually going to hit the surface of the Earth and cause the eclipse. So it's when the shadow hits when the moon is lined up, hitting that node point is when the shadow is lining up and pointing directly toward the sun and therefore directly hitting the surface of the Earth. Another kind of cool illustration with this animation is this is actually showing it to scale. So the moon and also the distance between the Earth and the moon here is to scale. And you can see, obviously, the sun's not on this scale because that would be really, really hard to show on one slide. So the sun is way off screen, off here to our left, about 400 times farther away than the Earth and the moon are shown in this animation. Here's one more animation. This is sort of a zoomed-in view of showing when the moon shadow, the umbra, is going to actually hit the Earth. So you can kind of see it from this angle, kind of watching from behind the moon as it's about to get lined up, kind of start to hit the surface of the Earth. Another kind of interesting thing about it, right? I mean, obviously this is scale and the apparent size of the moon in our sky and how it casts the shadow. And because of course, the distance between the Earth and the moon, Even though the original size of the shadow is the size of the moon, about a little over 2,200 miles in diameter, by the time it reaches us here on the Earth, it's less than 100 miles wide. So that shadow has gotten very minuscule, and that's why we have that umbral shadow only kind of carving out a small path across the continent. All right, one more animation to show, and just to kind of set this up. It's trying to show exactly so you can kind of pinpoint where you might be on August 21st. Sort of this color coding map is showing the percentage of how much essentially how much sunlight you're going to be receiving. So if it's that all white, that's at 100%. So no eclipse, no partial eclipse is happening quite yet. And as it goes from red to yellow to green, and then all the way kind of to that deep purple and black is when you might have totality if you're in those special locations. So you can see that partial eclipse is already happening on the west coast there and kind of into the middle of the country. And so as this kind of fast forwards in time, you'll see kind of the amount of light and the amount of the eclipse that's taking place across different places in the country. So it's happening now. You can see the totality kind of going across Oregon, Idaho, into Wyoming, a little bit into now Nebraska, a little bit into Kansas, kind of crisscrossing down there into Missouri, Tennessee, and then finally ending down there between sort of South Carolina and Georgia. And sort of as the sun moves in its apparent motion across the sky, we lose the partial eclipse, but hopefully you found your favorite spot in the country to go and observe this. And so if you are lucky enough to be at one of these places where totality will happen, and hopefully you have good weather and no clouds, here's a few kind of interesting things that you might look for. Some physical things that actually might happen depending on your location, depending on the observing conditions. So these aren't necessarily always going to happen at every location, but you can try and look for these things once totality is about to set in. So one thing that is interesting to look for is what they call shadow bands, so kind of coming up from the ground. And this would be just about a minute before totality. And these are essentially just going to be wavy, kind of moving little lines, essentially due to Earth's atmosphere. It's sort of refracting the last little bits, the last rays of sunlight that are coming through before they're being blocked. And so you look for these kind of shadow bands. It's starting to get pretty dark at this point. You can look for these kind of shadow bands on the ground the last minute or so before totality. Another cool effect that you might see is the diamond ring effect. And you can see this nicely highlighted in this image here on the upper left. And so they estimate it's usually about 10 to 15 seconds before totality and as well as after totality. And so as the sun is starting to be almost fully covered by the moon, you'll start to see on the edges, you'll start to see the solar corona becoming more and more visible. So you kind of get that nice ring effect, but then the last little kind of edge of the sun that's starting to be blocked, it's that nice kind of like jewel-like little effect, a little feature there. And so you can see it, aptly named, it looks like a diamond ring. So look for that right before totality and as well as right after, in the last, before and after the last few seconds. Also, again, as that diamond ring itself fades, and so as the sun kind of becomes almost fully blocked, the solar corona itself will become more fully prominent, more visible all around the edges there. Another cool effect, they're called Bailey beads. I think it's named after the person Bailey, don't remember the first name, but somebody Bailey who first noted this and discovered or observed this and noted it. And this happens kind of right before the last few seconds, right leading up to totality, and the last few seconds after totality are these kind of little globs or little bead-like appearances, these little blobs of light at the edge of the surface there of the moon. So they're called Bailey beads. And basically, this is just due to the fact that the moon is not a nice, smooth sphere, right? It's not completely smooth all around the edges. It has mountains. It has valleys. It's not a smooth surface. And so those changes in the surface height, the surface features of the moon, allow some sunlight to kind of pass, a little bit more to pass through, and more of it to already have been blocked, the higher places. And so you get these little kind of blobs, these little beads around there on the edges. And those are called Bailey beads. So this is sort of like the signature, like a totality. If you see these, totality is almost here, almost there. All right. Oh, sorry, I was going to take a quick poll. So this is what you would see if you were lucky enough to be in a place of totality. Just a quick show of hands. How many of you are planning to go drive, fly, be somewhere on totality? That's a good percentage here. I don't know, maybe 30% of the audience. That's awesome. Very exciting. If you aren't able to travel, that's okay. You still can see some really cool things happening even here in Austin. So what might you expect locally here in Austin? Well, the partial eclipse will start just a little after 11:30 that morning, and we'll have almost 3 hours of partial solar eclipse happening that will take place. The maximum partial solar eclipse is going to happen just after a little after 1 p.m., and you're going to see a good amount of that crescent moon there, crescent sun there. So you'll see a nice partial eclipse, and you have a few hours to observe that. And so we're here in Austin. The partial solar eclipse is about 65%. So 65% of the sun will be covered here in Austin. If you're a little bit more north, like in Dallas or something, you have even more, a little over 70%. All right, so what to expect if you're not here at totality, or even if you are somewhere in totality. Always, the nice safety reminder, make sure you have something to view the solar eclipse safely with, those nice eclipse glasses. You can get little welder's glass. I'll show you a few other options you can do that with. So this is kind of cool. I just found this. I was looking for examples of people watching a solar eclipse or a partial solar eclipse. And this is actually from a bar here in Austin. I didn't recognize the bar, if anybody does recognize it. All right, there you go, Red Sports. Awesome. There we go. All right, so some astronomy folks actually went out. They're from an astronomy organization, went out and just passed out solar eclipse glasses to people that were just hanging out in this bar for the partial eclipse that was happening here in 2012. I think most of these people probably didn't even have any idea that was going on. It was less publicized, but just by, hey, look, check this out, passing out solar eclipse glasses, all these people got to kind of join in the fun. So again, quick safety reminder, use your eclipse glasses or some other way to safely view the sun during the eclipse, except for that, if you are in totality, only during that point of totality, it is safe to view it without it, but only during those exact moments of totality. So hey, if you're here, get some eclipse glasses, go to your favorite bar and hand them out and get everybody else excited about it. Other cool ways to view the solar eclipse, use a pinhole camera. There's lots of good resources online to how you can make one. This one, the upper left, just comes from timeanddate.com, but you can make a pinhole camera, project the image of the sun and the moon down through your pinhole camera onto a piece of paper. You'll see that nice image of the the crescent sun there. Here's an example on the lower left. You can also just use other things you have around your home or outside. You can use a colander. So get out your colander from your kitchen drawer and you project the sunlight through that, and you'll see actual crescent suns being projected through those using your colander as a pinhole camera. Or you can just use nature. So that image there on the upper right is just showing a partial solar eclipse being viewed through tree leaves. And so if you go out and you see, normally we see the disk of the sun. Those tree leaves act as a pinhole camera, and you'll see that full disk of the sun. They might be overlapping somewhat, but during the solar eclipse, it's going to look a little bit different. You're actually going to see the shape that you're seeing. You're going to see that crescent sun. So pretty cool effect you can see even in places where you don't get totality. So the question was, how much does focus matter? I don't think it matters a lot. You basically just need to get it aligned right with your image. And there's directions online about the right ideal size of a pinhole of the pinhole itself. But yeah, and you just have to get whatever you're projecting it on to be at the right. It's not too far, but just at the right distance for where you see a nice in-focus image of the projection. All right, so very last slide. If we can't make it to totality here, and if you're in Austin, you're going to be still here. Don't fear, just hang around for another 7 years, less than 7 years. Stick around. Texas a large portion of Texas will be in totality for the April 2024 solar eclipse, and Austin itself isn't in totality. You can see we're kind of right there on the very edge, right here, but we will experience totality. If you're in San Antonio, you just got to go a little bit more north and west. Even being on the edge for this eclipse, Austin will have almost 2 minutes of totality. And if you're even a little bit farther north or even a little bit more inwards toward the center line of the total eclipse, you're going to have upwards of 4 minutes of totality. So pretty cool eclipse that will happen here on April 8th, 2024, right in the middle of the day. It's going to start in Austin around 1:30 p.m. So hang around. You're an Austinite. It's coming soon. All right. Thank you. I'll take questions now.
All right. Thank you, Silver Surfer. Questions? Whoa. All right. All right. Okay.
Yeah, so there's this thing of Eclipse Chasers, and the exact time, I think it depends on how well or what if you're in a plane or whatever. But yeah, you could follow that. I mean, this the eclipse that's happening. It's going across the whole country. It's starting at 9 a.m. Pacific time, so it would be about 12 p.m. Eastern, and then it's going all the way to about 4 p.m. Eastern. So you'd have 4 hours where you could chase this, presumably. Yeah, I don't know what the speed is, so I don't what type of planes. Yeah, so they do this. There are eclipse chasers where they can kind of follow it for a shorter period. They're not chasing it this whole time.
I don't want to drive in front of you, sir. All right, other questions? Right up front.
Yeah, so the question was, if you could go anywhere in the country and money's no object, where would you go? So I've looked at, I'm originally from the Pacific Northwest. I'm from Oregon. I was born in Salem, Oregon. I'm actually going back there to watch it. We're kind of on the western side of the mountains. I've actually heard that the eastern side of Oregon is the best location. So if you could head to the eastern half of Oregon, near Madras, Oregon, Redmond, Oregon, that's supposed to be one of the better locations. Prineville, right outside of Bend, Oregon. Yep.
So everybody go to Keely's house in Oregon. All right, up top.
So technology is obviously advanced in today's and Albert Einstein. What kind of instrumentation would an amateur astronomer need to view the bending of light by the sun?
That's a tough question, and it's probably out of my realm of. So the question was, technology has changed a lot since when people were first able to measure the bending, like the relativistic effects of light during the solar eclipse, so measuring the bending of light. What type of equipment would an amateur astronomer need nowadays to try and redo that experiment? Is that kind of the question? And I honestly don't know the level of equipment. I don't know if anybody else in the audience knows this.
I'll take a stab. So, I mean, you're looking for some sort of bright star behind it that's moved in position, right? So you need the actual position of the star. So probably similar equipment to what you've done before. You just need to know exactly what the position of the star is before and after. So, but yeah, I think there's some hands that have some ideas, possibly. All right, question.
I was wondering if anyone has predicted what the brightest star is that will be behind or occultated, I guess occultated.
So the question was, what is the brightest star that might be occultated during the solar eclipse? And I actually don't know that either. Could look it up, but
That's a very good question. Not sure.
yeah.
It'll be a star that's probably close to the constellation Leo.
Yeah.
So the comment was star close to the constellation of Leo. All right, in the back.
Yeah, again, so probably doing this during times of, right up to leading up to totality and stuff. So if you have like a solar viewing telescope that you could project and be able to see that, and as it gets darker, you could still see some solar flares during, if they're there, yeah.
Okay, one more question up to the top.
So I think the question was about the type of welding glass. And all right, somebody in the audience is answering this for me, which is awesome because I wouldn't have known. But yes, so number 14 as a minimum. All right. This is awesome.
All right, if you have any more questions, you can find Silver Surfer during intermission. Let's thank her one more time.